I'm Brian Toon. I'm the chair of the Atmospheric and Oceanic Sciences Department at the University of Colorado, and I'm also the campaign leader for SEAC4RS, which is NASA EASE for the Southeast Asia Composition, Clouds, and Climate Coupling Regional Experiment, which is a large multi-aircraft study of the way that air pollution and natural emissions of gases occur in Southeast Asia, and how these gases are carried upward in the atmosphere by big thunderstorms and convective clouds. And we can see from satellites that once it gets into the upper atmosphere, that this material then gets carried up over the Himalayan mountains and then into the stratosphere. And we're interested in it because once it gets into the stratosphere, it becomes global and can affect the entire Earth. Southeast Asia has a very large fraction of the Earth's population, perhaps half of it. So there's huge population there with many megacities. There's a lot of air pollution coming from all those people, of course. But it's also a part of the world where there's large rainforests and large expanses of ocean, a lot of shipping concentrated in narrow straits. So there's both natural and human sources of air pollution there, and we don't know very much about it. We have 4 aircraft that will be involved in this mission. One is a Gulfstream 5 from the National Center for Atmospheric Research. That's a National Science Foundation airplane, which is a research aircraft that's heavily instrumented. Then NASA has a DC-8, which is a commercial airliner that's been converted into a research platform. It has a large number of instruments on it that measure the chemistry of the atmosphere, the properties of clouds, the properties of little particles in the atmosphere, the radiation budget. Then we also have a NASA ER-2, which is a high altitude plane like the old U-2s. And this aircraft is instrumented to be a sort of a satellite surrogate. So it's very hard to test satellite instruments because the satellites go whipping by really fast, and so you can't stay under them very long. So it's much more efficient to take satellite instruments and put them on an airplane and then fly another airplane below that one. And that way we can use the same techniques to measure what's below the airplane that a satellite would use, and then we can fly the second airplane through the scene that was being observed by the satellite surrogate and see what's actually there.